Hello there, today we'll be doing remove nth node from the end of the list. So in this example 1, we're trying to remove the second item from the end of the list. So this is n equals 2. We're trying to remove the nth item from end of a linked list. So in this linked list, we only have a value and a node. So we have two values. One is value, and then we have a pointer called the next, which points to 2, points to 3, points to 4, and points to 5, and 5 points to a null. And what we're looking to do is remove the second item from the end, which is this. This is the second item from the end. This is the first item from the end. This is the third item from the end, and this is the fourth item, and this is the fifth item. N can be between 1 and the number of nodes, so n cannot be out of bounds. We have a maximum of 30 nodes possible. So, and one node minimum, so we can remove one node. The values are between 0 and 100, which does not matter very much. Okay, so here are edge cases. And we have 1 through 30. And we have 1 through 29 as this particular output. Okay, so the time complexity is going to be O of n because we're going to have to read all of these nodes to get to the nth node. Doesn't matter whether we're removing the first node or the last node. If we remove the first node, we have to find a way to realize that this is 5 nodes over. Suppose we have a slow and fast pointer. Of course, this also means that we need a dummy node, just in case we want to remove this 1 here. So we need a dummy node to point to the rest of these nodes. Okay, so suppose we need to remove the last node. This would mean that we would need to move the fast pointer 1, 2, 3, 4, 5 times. Here. And well, we're trying to remove that one at the end. So we remove it once. And by moving it once, we can move the slow pointer forward until the fast pointer points at this particular item, the first item, and then we point the slow pointer to the slow pointer .next or fast .next. That doesn't make sense. Yeah, so we just point at slow.next. So slow.next is equal to next, the slow.next, which means it points to null at this point, and that means we have the correct answer, 1, 2, 3, 4. If suppose we want to remove the first item, we have to move this 5 times forward, and then when we move this, we have to move it 5 times forward. Yeah. And that way, when we see that we are done here, we can set the slow.next to point to 2, the start item at 2, and then we would remove the 1, and we would have 2, 3, 4, 5, which we want to return. So again, we have to go, this is going to be a 1, this is 2, this is 3, this is 4, this is 5. All right, perfect. Okay. So time and complexity is O of n, but in this case, we are bounded by 30 items. So it's O of 30. and which means it's O of essentially O of 1, but we can think of it as O of n. And space is going to be O of 1 because we do need a dummy node. We do need a slow node, a slow pointer. And a fast pointer. So with those, we are ready to match the pattern, which I think we pretty much did already. It's the fast and slow pointer. And we have a plan. So these are the words that we have just said in our little case here. So we need 1, create dummy node. We need to create a slow pointer, fast pointer. Okay, link slow dummy node to our the head of the head of the linked list. 3, move the fast pointer n times, and 4, while fast pointer dot next exists, move both slow and fast pointer. Lastly, we're gonna point slow pointer dot next to slow pointer dot next dot next. Okay, well that's our plan, and we're gonna implement it now. So what we're gonna do first, as we are running out of space, we're gonna move our implementation to the top, and we're gonna then do the review and evaluation, and we'll be on our way to the next problem. So let's first create our dummy node, which is equal to a slow pointer, which is equal to our fast pointer, which is equal to a list node. Let's just create it. Perfect. We can also create this all in one line. We can set value equals 0. We can just set this to 0, and we can set this to head. I'm sure that this can be done. Let me just run the code. Well, we'll run the code later to make sure that works all in one line. Okay, let's go to the next step. So A, check, done. Linked list to head of linked list, dummy node to head of linked list, done. Okay, move the fast pointer n times. So yes, it has been moved n times. Perfect. And while fast pointer dot next, we're gonna move the slow pointer dot next, and the fast pointer. Looks like we need to set these as lowercase. I think it just looks better. All right, all good. Lastly, once that is done, we can just point the slow pointer dot next to slow pointer dot next dot next. This problem is basically a very visual type problem. I don't think I'll be able to do it if I did not have this image. So that's the lesson here, just to get the image. Okay, so now once we're all done, we can return the dummy node dot next. All done. So let's review with a couple edge cases. Or I think we should do a regular case and then do our edge cases. So our regular case is the 5 items. So first of all, we have a slow, fast, and a dummy node created, and it's linked to our whole linked list, right? And now we move the fast pointer n times, which is going to be 2 times. So 1, 2, done moving. Now the slow pointer and fast pointer moves lockstep until this particular location at the 5. So we move it all the way here to the 5, and then now that slow is at 3. We point slow dot pointer dot next. So dot next is equal to slow pointer dot next, which is 5. So we remove that, and now we have 1, 2, 3, 5, which is what we wanted. And we return dummy node dot next, which is going to be our 1, and we have returned our linked list. Perfect. So let's check out the second problem. So in our second problem, what we have here is a single item. We have a dummy node, slow pointer, fast pointer, and we're going to point to our single item, so 1. And what we do here is that we're going to move to fast pointer once. So fast pointer is moved once, and now we are 1 away from the end, so that is the end. So slow pointer points to slow pointer dot next. So that points to none, and that's what we returned. Return none. Perfect. Lastly, we're gonna have to do all 30 items. So what happens? Well, I think let's just let the compiler do this. But I mean, we can imagine that if it works for 5, it works for 30. Okay, so let's just run the code and submit. Okay, with that, let's evaluate the runtime of this problem. So based on my evaluation, so the runtime is going to be O of n, as we expected earlier, right here. So let's just set our evaluation here. And it's O of n because of the loops. We have to go through every single item in the linked list. And that, in this case, is O of 30, and that is O of 1. And for space, we did only use 3 items, 3 pointers, so it's O of 3, which is O of 1. I think everything looks good. If you have any questions, please comment below. If you enjoyed the video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one. Thank you. Bye.